Hello, my name is Olivier Prue, and this video is an accompanying video to my PDF titled Unity Custom Rule Tile System. In this video, I will seek out to show you the functionality of my system as well as go a little more in-depth on the code. On the user end, I tried to make the system very customizable. So here in the random level generator, you can customize the width, height, the length of this little dock area here, and the scale of the noise, giving the terrain a vastly different look, as I'll demonstrate here. Very different. Now, I like the settings I had dialed in here because I felt like it gave a very cohesive look. The tiles that are generated into the world are also customizable using this colors gradient here. If I were to change this gradient, I could change how the tiles are distributed or even add a new tile. For example, if I take these out, I can use this color here, which wasn't used previously, and generate a new level. And now we have a sort of interior scene being built up. The tiles themselves are scriptable objects. They store 14 different game objects that can be added into the scene and rotated to create any closed shape. The map interpreter is the script that gets called when you press the generate level button. The function is map2array, which starts by opening up a 2D array and calling on our random level generator script to generate a texture for it to process. The random level generator script uses Perlin noise, which I have in a function down here, to color the map. Then that Perlin noise is multiplied by a falloff texture, which is generated here, which just sets the pixel's brightness to how close it is to the center of the screen, thus making it more likely for more things to be in the center than on the outskirts of the texture. Once the texture is generated, I evaluate it to the gradient called colors that I showed you earlier, and that gives us our final texture. The texture is then returned to the map interpreter, which reads the data from the texture and loads it into a 2D array of strings. In the 2D array of strings, every tile that represents every filled tile is represented by a 1, and every empty tile is represented by a 0. Once the array is built, it's sent over to the rule encoder script. The rule encoder script job is to encode more data into each cell of the 2D array. In this case, the data is whether or not the surrounding cells are filled or empty. If the cells are empty, we add data to show which cells are empty, which is controlled by this series of if statements. Once that data is returned, it's passed into the maploader script. The maploader script is comprised of a very long switch statement. This switch statement has a case for every possible combination of letters. Once the correct combination of letters is located, a 3D model is put into the world at the correct rotation to represent its tile. After all this is done, the result is a seamless tile system.